Hi everyone, welcome to another video. Now in the previous video we spent a lot of time defining and deriving, I should say, the quadratic formula. So I have written that down here, and we noticed that the quadratic formula is really just what happens when we apply completing the square, factorization by completing the square, to any particular quadratic equation. So these, we said, were those in the form of ax squared plus bx plus c. And we said that, okay, once we've defined this for any quadratic equation, and let's actually just make a note of that. This is any, we'll do QE for quadratic equation. So any quadratic equation, when it can't be solved using, for example, factorization by PSF, which we talked about, we can either use completing the square or the quadratic equation. Now, what's nice about the quadratic equation is that it considers all of our elements here, and it maps them into a point on the equation. So when we actually go about solving these, it just becomes a matter of substituting each of the coefficients, the values of the coefficients, into our quadratic formula, and then finding the solution for x. So we've spent a lot of time deriving this and looking at how this works. So in this video, I just want to jump straight into a couple of questions so we can practice. Now, here I have some kind of quadratic equation, and in order to use my quadratic formula, I need to make a note of what my coefficients are, what my numbers in front of x squared, x, and my constant at the end are. So in other words, I want to see, all right, what does a equal to, what does b equal to, and what does c equal to? Now, we can see that for a, there's no number in front of x squared. There's nothing explicitly written down. And thinking way back to when we first looked at algebra, we said that if there's nothing in front, we can think of there being like an imaginary 1 in front of it. Because to get x squared, 1 times x squared gives me x squared. So the coefficient in front of x squared is going to be 1 here. Whenever we don't have a coefficient, we assume the coefficient is 1. So therefore, a equals to 1. And b, from our general formula for my quadratic equation, that is the coefficient of x. So I want to read through and see, okay, 5 is that coefficient of x, so I'm going to put that there. And c here is just my constant at the end. So I have positive 3 here. And now it just comes down to, let's write out my quadratic formula, because it's going to help us to remember it if we keep writing it out. So x equals to negative b plus or minus. So remember, there's two solutions usually, and we'll talk about something else related to that in the next video. Now, there's a plus or minus, which means one solution will be the positive here, minus b plus whatever over 2a, and a negative solution too. So we're expecting roughly 2 solutions when we use this formula, but not necessarily. So that's a little idea for later, which we'll explore. So the rest of our quadratic formula is square root of b squared minus 4ac all over 2a. And now it's just a matter of substituting these values in. And we want to be really careful here when you do this, and this is where a lot of students struggle with the quadratic equation, is they get their signs mixed up, and it becomes a little bit harder to do. because we have to be careful of these signs here, as well as the signs of my coefficients a, b, and c. Okay, but here, to start filling these in, I just want to put b in place of all of these b's. My value of 5, sorry, in place of these b's. So I'm going to get minus 5 plus or minus the square root of 5 squared minus 4, and 4 is here getting multiplied by a and c. So let's put those numbers in as well. 4 is getting multiplied by 1, which is getting multiplied by 3. And that is going to be all over 2 times my a, or 2 times 1, which just gives me 2. But let's write that all in so we can practice. Okay, so now we just want to figure out, well, we just want to simplify these expressions and get our 2 solutions of my quadratic equation here. So this gives me 25 when I square 5, and that's minus 12. And that is all over 2. Okay, cool. And now it just comes down to doing my 25 minus 12. So that gives me minus 5 plus or minus the square root of 13 over 2. So here I can see there are in fact 2 solutions because of this plus or minus here. So therefore my solutions are going to be, one of them is that x equals to minus 5 plus root 13 over 2. And another one is going to be that x equals to negative 5 minus root 13 all over 2. So this is how we can use the quadratic formula. It's just a matter of writing out the formula, identifying our coefficients, or in other words, my a, b, and c, and just substituting those into the quadratic formula. Now let's look at what happens when I get negative coefficients, because this is what trips up a lot of students. So once again, I want to write down what's my a, what's my b, and what's my c. Okay, so a here is positive 2. I can put that here. My b, however, because of my general formula, my general form of my quadratic equations are ax squared plus bx plus c. So since this is negative, I can think of this as 2x squared plus minus 2. So my coefficient of b is a negative number. This is going to be negative 2 here. And the same thing here down the end for c, I have that adding to negative 1. That's why there's just a minus there. So my c here is negative 1. And now that I have all of these here, I can substitute these values into my quadratic formula. So I get minus b plus or minus the square root of b squared minus 4ac all over 2a. Okay, so like the last question, we just want to substitute these in. And I'm going to take a lot of care to write everything in. So to write in the entire values, especially when we look at negative numbers here. And we'll see where some students can get really confused. So a lot of the time, students will see, okay, there's a negative here, and there's a negative here. So cool, I'll just write 2 in the place of b. However, we have to substitute in negative 2 for b. So here we're going to get minus 2. I'm going to put brackets around this to make it even easier to identify. And I get the square root of b squared. So that is negative 2 all squared. Remember, in the place of b, I have to put my value, and in this case, this is negative. And from that, I'm going to subtract 4 times 2 times negative 1. And I've just written these multiplications with brackets here. But we can keep going, and in place of a, I'm just going to put 2 down the bottom. So 2 times 2. Okay, let's try to simplify this a little bit. Now here I have minus 2. Now if I have two negatives, negative lots of negative 2, that's going to give me a positive. So instead of minus 2, I'm just going to put 2. Positive 2. And here I'm going to subtract negative 2 squared. That's like saying negative 2 times negative 2, which gives me a positive number because we have a double negative. So that's going to be 4 minus, and I have 4 times 2 times negative 1. That's minus 4 times 2 times negative 1. And that is going to be over 4 here. Alright, now I'm working really slowly through this just so we can eliminate any mistakes we may make. Now, what's happening here? I have minus 4 times positive 2 times negative 1. I have a negative times a positive times a negative. Now, notice here I have, in fact, 2 negatives multiplying by one another. So that is going to give me a positive. So here I have minus 4 times minus 1. That's going to give me 4. And I'm multiplying that by 2 here. So that's going to give me plus 8. Because minus 4 times 2 times minus 1, that's going to give us a positive number. So instead of these negatives, I'm going to put 4 plus 8 here. Okay. So we are getting closer. I have here 2 plus or minus the square root of 12 over 4. Now, I can have this as my answer, but we can try to simplify these solutions as well once we get to this point down the bottom here. Now, notice that root 12, I can split that up into root 4 multiplied by root 3. Because from our surd simplification, when we looked at those, we learned that 2 surds can multiply to give me a new surd, or we can break down that surd into its factors. And if one of those is a perfect square, then we can pull it out and get an integer in front. So let's look at how that's going to work. Now this square root of 4, if I take the square root of 4, that's going to equal to 2. So I'm going to end up with 2 plus or minus 2 root 3 over 4. Now let's think, is there anything I can pull out of the top and the bottom? Is there a common factor that goes into this one as well as this one? Well, I can see that a 2, the number 2 goes into both 2 and 2 root 3, and it also goes into 4. So I can pull out 2 outside of, now here I'm going to get 1 plus or minus 1 root 3. And I have 2 here multiplied by 4. Sorry, 2 multiplied by 2 to give me 4. Now these two here are going to cancel out. Because here I have 2 over 2. I can cancel out that common factor from top and bottom. And that's going to leave me with 1 plus. Now 1 root 3 is just like saying 1 times root 3. If we times a number, multiply a number by 1, it just gives us that number. So we're going to get 1 plus or minus root 3 over 2 on the bottom. And as we said before, this gives us 2 solutions because of this plus minus idea. So we have that x equals 2. One of my solutions of x is 1 plus root 3 over 2. And the other is going to be 1 minus root 3 over 2. So this is how we can apply the quadratic formula to solving any quadratic equation we are given. It just comes down to identifying what our coefficients are, substituting them into the formula, which doesn't change, by the way. The formula is always x equals minus b plus or minus square root of b squared minus 4ac over 2a. And then sometimes, well, we do the operations here to simplify. And sometimes when we get to the end, we can simplify my quadratic expression here. Oh, sorry, we can simplify my 2 solutions. So here it required a bit of surd simplification as well as pulling out a common factor from top and bottom. But that is how we can use the quadratic formula to solve quadratic equations. Thank you so much for joining me on this video, and I will see you next time.